Hey, it's Brent. I'm in EC 311 and 331, so I'm going to be talking about our power management system based on things that we learned in those two classes. I will not be talking about EC 341 related concepts because I already took that class, so I don't need to. I could, but I won't. So looking at our power management system right here, we have an AC source, a full bridge rectifier, and an RC circuit. The capacitor in the RC circuit is pretty important, and I'll get to that soon. I'm going to first look at things that relate to 311. We want to acknowledge that this circuit's not linear because of varying inputs. So when we have our input from the AC source, we could have a leading edge or a trailing edge. And as you can see, those are not the same, but they both yield the same result of the full wave rectifier, full bridge rectifier, which is right here. The system is time invariant because there's no variation in the diode response or from the RC circuit. And the whole system's linear because all of the systems are linear components. In order to convert from AC to DC, because you can't just do that in an LTI. The rectifier is essential for that. Those diodes in the rectifier do that. And lastly, the system's periodic because we see a periodic output coming from a periodic input. Now talking about 331 things. So as you can see here, we have the rectifier. The rectifier produces this output typically, which is what we want because we want both the peaks of the VPP input to be showing up on the positive end so that we have something of a positive voltage source. And then that's where the capacitor comes in. That smooths the input, as you can see right here. The capacitor charges and discharges on each rising cycle of the circuit. And we can't get a perfectly straight DC line for that, but it'll be close enough, and with better chosen capacitor values, we can almost create that flat line. I am not taking EC 341, so I'm not going to talk about how this system would work in terms of electromagnetics. Does seem interesting though. In conclusion, I just want to say that this was an interesting KI. I really like charging my phone, and the AC to DC converter that's in every single little charging block we have is very important. It's pretty cool to learn about it. What I don't like is transfer functions. One of the problems we had involved using a transfer function on paper. I didn't know how to do that, but I got it done. Thank you for watching this video. This is the end of KI1.